This restaurant's been open for over 10 years and there's an improper wiring of a smoke detector. The crazy thing is how is that possible? The fire marshal is supposed to come and inspect the restaurants every so often, or they get a fire inspection on behalf of the fire marshal, and someone's clearly not testing these units to see if they're working right. This is the crazy thing is I can find stuff after restaurants have been in operation for years and years and years.
This video is brought to you by Sporlan, quality, integrity, and tradition.
Today we have a service call on literally every AC not working. So last night the customer called saying that the dining room AC wasn't working. And then when I called, asked them if they wanted overtime, they said no. Later, after that phone call, progressively they put in a work order for this unit and the other unit saying all the ACs were down. I suspect that it's going to be a smoke detector problem if all the ACs go down, but let's open these up and have a look. So this is their dining room AC. And it's hard for you guys to see, but it says smoke, S-M-O-K-E. These boards are just a joke. So this one has a tripped smoke detector. Let's move on. Well, it might not be that it's tripped actually, because what can actually happen is that if they're globally connected, one can trip and it makes everyone think that they're tripped. So I don't necessarily see a red light in this one. So basically they could be backfeeding through something. I'd have to look and see. But let's go look at the other ACs too. This is one of their ACs. Oh, it says smoke too. It's hard for you guys. These, for some reason, this display, it's like the refresh rate of the phone. It can't pick it up. You can like barely see it every once in a while if you get at the right angle where it says smoke, S-M-O-K-E. And then we come over to their last AC, and the last AC over here says the same thing, smoke, S-M-O-K-E. So smoke detectors, one of them's tripped at least. So let's pull the covers. These things are pretty dusty. We'll pull the covers, see if we can figure out which detector's tripped. Smoke detectors, depending on what type and what brand you're working with, you have to be careful about taking covers off. There is tamper sensors sometimes under the covers. Now, this right here is one that has a remote sampling station or sensor, right? So there's a separate part in the supply or the return section. And this is just the control module. So we are safe on this one to pull this cover off, but you just still got to be careful. So we'll pull the 3 screws, then we'll pull that off. But you got to understand that sometimes these things will have a tamper sensor. If someone messes with it, it's going to trigger some sort of a trouble alarm, basically. Okay, so go ahead and pull the cover off this one, and then we'll do the same for the other one. Now this one doesn't have the tamper alarm underneath it, but what they do have, you can tell that the way that this is wired is they have it wired for trouble. So basically, if we did pull or if we turn off power to this unit, they are going to get a trouble signal at the fire alarm panel. I can tell by the way the resistor has jumped across the contacts. Because instead, if it was wired up just to simply monitor the circuit and trigger the alarm if necessary, then this resistor right here would be strictly across the common and normally open of the alarm contact, as opposed to being tied into the supervisory circuit. So this one, because the resistor is tied into the supervisory circuit, tells me that if we power this unit off, they are going to get a trouble condition depending on where this smoke detector is powered from. This smoke detector is powered from this board right here, so therefore they will get a trouble condition if we power the unit down. Now they're currently in a test mode, and I know that because we have a smoke detector trip somewhere and the fire department's not here. So clearly something happened yesterday, you know, whatever. So this one looks to be in trouble. It's yellow, but it's not red. If it was red, then it would be tripped. So we're gonna go to the next one. So just set the cover up there. Let's move on over here to this next one. We'll do the same thing. See if we can figure out which one is actually tripped. This one is tripped. It's got a red solid LED light. So this is our problem one. This is their kitchen AC, I believe, which makes sense. So the kitchen AC has a tripped smoke detector, which can happen for various reasons. It can happen because there's truly was smoke in the ductwork. Maybe the blower motor's going bad and it blew a puff of smoke, let the magic smoke out, and it triggered it. Who knows? It could be that one of the exhaust fan hoods is not working and they're getting smoke rolling out of the hood. I mean, there could be all kinds of things. So we don't just reset a smoke detector and move on. We're going to keep going to the next unit, make sure the next unit isn't triggered either. We'll come over here, pull the cover off, and then we can proceed further. So this one has a green LED light. It's flashing green. So that's a good sign. So the other smoke detectors are not tripped. It's not a global shutdown, I don't think. Well, it still could be in theory, actually. No, it still could be. But I think if they had a global shutdown, all the smoke detectors would be red, I think. But maybe not. No, because look, there's nothing coming up into here. If it was just interlinked wiring, it would be tying in right here in these three, and it's not. Something's telling this unit that it's in smoke mode, though. So something's going on. There's some sort of a shutdown somewhere. It's probably in this wiring that they're doing it. Okay, so we are going to go ahead and reset the other AC, but before we do that, we're going to come over here. We're going to go ahead and open this guy up. We're going to shut down the unit at the disconnect switch, and we're going to investigate to see if there's... Oh, that's really interesting. This guy has a tripped smoke detector, but the blower motor was running. I was opening this up to see if the blower motor was a problem, but it's not because the blower motor was running. So that smoke detector, something's wrong here. If we had a smoke signal to that board, this should not be running. Something's... Oh wait, is it... No, the VFD is not bypassed in this. Why was this running? Look at the smoke detector still tripped. Still red, meaning that it doesn't get its power from this unit. What is going on here? Something is wrong. Really wrong with the wiring or something in this unit. Oh, look right here. See these two wires? There you go. Those are going to be some sort of a signal for the smoke detectors. Someone has disconnected something. But what's really odd is that the board is recognizing they have a tripped smoke detector. That should have shut down the unit completely. This is really, really odd. I'm curious. So this blower is not running because the VFD has been bypassed and there's a contactor. The contactor's not pulled in. This one, though, is not tripped. But still, yeah, see, if you see smoke across here, the board is getting a signal. The unit should be shut down on emergency stop. And this one was not. That's really interesting. Let's look at this one real quick. This is a interesting problem. This one's not running. There's the sensor, by the way. So those smoke detectors are allowed to have a remote sensor. Sometimes they have two. This one does not. This one only has one. Oh, look, there's a balloon. Woo! Balloons get sucked up into these. Their maintenance is due, so we may or may not get to that today. So yeah, this right here seems to be doing the proper shutdown, but this one is not. That is really interesting. So that's a problem. Okay. So I'm intrigued as to where this smoke detector is getting its power from. Because these wires should be the power wires for this guy. Instead, they are wired in right here to other smoke detectors or something, or the fire alarm panel, and they're bringing wires going somewhere else. So this thing's got some goofy wiring here. Something's wrong. You know, the crazy thing is we can find this stuff. This restaurant's been open for probably 6-7 years. 2014. So this restaurant's been open for over 10 years, and there's an improper wiring of a smoke detector. The crazy thing is how is that possible? The fire marshal is supposed to come and inspect the restaurants every so often, or they get a fire inspection on behalf of the fire marshal. and someone's clearly not testing these units to see if they're working right. This is the crazy thing, is I can find stuff after restaurants have been in operation for years and years and years where smoke detectors are not wired or working right. Just recently, we were at another restaurant and they had a trip smoke detector. We reset it, couldn't find anything wrong. We went back another morning to go investigate the smoke detectors and realized none of them had the sampling tubes in them. All 3 of them, none of them. And it's like, how long has that been like that? Like, it's interesting sometimes what you find in these restaurants. All right, here's what we're doing. We are running a test. We are gonna shut down the other ACs and see if this smoke detector loses power. Go ahead and shut that one down. We're waiting here. Is it off? Okay, turn it back on. So it wasn't that unit. They might be getting it from the fire alarm panel. So let's go back to the other unit. Go to the next one. We're looking to see if one of these units shuts down power to this detector. Go ahead. There we go. So we lost power to the detector when that unit over here was powered off. So this unit has the control for the smoke detector right here. This is odd the way that they did this. This is very odd. Okay, go ahead and turn this unit back on. So this one is the one that was not tripped. This is the one that seems to control the voltage to the other detectors. Okay. So now what we're gonna do is we are gonna reset this smoke detector. Oh, it reset when we power cycled it. Messing with duct detectors, smoke detectors can be kind of intimidating sometimes because there's a lot of wires, and if you do something wrong, the audible fire alarm goes off in the building. You know, that kind of stuff. So first and foremost, you always want to put stuff on test before you start messing with them. I'm assuming this is on test, but before I start doing any unwiring and things, we are going to actually go down and have the manager confirm that it's on test, put it on test for 8 hours just to be safe. Then that way, in theory, if it's on test for 8 hours, if we do trigger the alarm, it'll still trigger the audible alarm in the building. The strobes will start going off, but it won't call the fire department if everything is wired correctly. So that's what we need to do. But when you're looking at these things, it can be intimidating. But just for the most part, majority of the time, each jacket has one function. Okay, so this red one has 4 wires. Just start looking at where they're going. One's going to reset, one's going to test. That is the test and reset station in the manager's office. So then you can kind of eliminate that from your thing, and then it makes it make a little more sense. Then you've got some power wires, you've got an alarm wire, black and red, that's bouncing between a couple different things. In fact, what the heck? This isn't even wired right. Oh no, it is. Yeah, this is wired right. No, I still don't think it's wired right. But anyways, yeah, so really there's not a whole lot going on here, but I don't understand how this isn't shutting down the blower. This is really odd. Oh, wait, because I think that because these aren't wired maybe, but still it said smoke on the blower, so why didn't it turn the blower off? All right, the wires that aren't hooked up should be going to 24 volts from the unit. Got to get my chopstick action going on here. So those have unit voltage. So, I'm still intrigued as to why this didn't trigger. So what we're gonna do is we're gonna unwire the alarm, and we are gonna, that way we can trigger the unit and do some testing, make sure everything's good. Came downstairs to have the manager put the fire alarm in test. We requested it be in test for 8 hours so that way I can unwire the alarm. I'm gonna unwire the alarm, that way we can just trigger each unit and test the functions, make sure. We're gonna start by seeing if these units shut down, the other ones, like they're supposed to. We're looking at the returns because if smoke did make it up, it more than likely came through the return or through the outside air filter. They are by a freeway here, so it's possible that it was a car fire or something like that too. But you would think the other ACs would have been triggered too. So who knows, but we're just looking at the returns, making sure they're clean. We'll go to the other ACs too, but then we'll head back up top. This restaurant happens to have an unconventional return system. There's no grate, no grill. I know for a fact, well, I don't know for a fact. I'm pretty sure there's no grate or grill on top of that. It's just an open return. And it pulls from the attic or ceiling up in there, and then you can see the supply diffusers running this way. Both of these, this is their bar unit, and then if we come over here, right over to here, you can see their dining room unit. Dining room unit's doing kind of the same thing, where we've got this big giant return plenum with just 2 open returns. You can tell because it's all dusty in the attic, and then the supply diffusers are all coming out on the other side, running all the way down. The manager has put the fire alarm on test for 8 hours, so we're safe there. So now what we're gonna do, we confirmed all the exhaust fans are working, so because we wanted to know if that had anything to do with what we're doing. They're all working. We are gonna unwire the fire alarm, and we are gonna trigger each individual unit to see how it functions when we trigger it at the detector. So we're gonna start with this one right here, which was the problem one. And I'm gonna unwire the fire alarm so that way it doesn't trigger it, essentially. So even though we put the system on test, that's for monitoring. But locally, we can still set off the fire alarm if we trigger this. Sometimes it does, sometimes it doesn't. It just depends on each location. So that's why we're still being cautious, and we typically don't wanna do this when there's customers in the building. This is early in the morning. So I'm gonna go ahead and unwire these. So the way that the fire alarm, they're monitoring 2 wires. They're looking for a direct short or a resistor. If they see the resistor, they know that the wiring is good and intact. It's to prove the circuit, essentially. So they put this resistor across those 2 wires, and they're always looking for that resistance unless they see a direct short. If they see a direct short, then that means that there's a fire condition. So they monitor on this situation. There might be other ones that do it differently, but this one, they're looking for 2 conditions. They're looking for a resistor, and they're looking for a direct short, okay? If the resistor disappears, the way that this one's wired, it means there could be a trouble or a broken wire. So, because this is a supervisory. So if we power cycle this unit and it's wired correctly, which this one isn't, then we turn it off, they're gonna lose sight of that resistor because the way it's wired into the supervisory contact on here. Someone has been in here. We were looking at this carefully. Look at this one is not even wired in. It's just sitting there. So yeah, someone's done some weird stuff. So we're gonna rewire this and make it work right. Yeah, something's off here. Someone's disconnected this. Someone was up here playing that didn't know what they were doing is what happened. We're carefully pulling the resistor out. We don't want to lose that. And then now we're going to proceed to disconnect the wiring going to this alarm contact without letting any of the wires touch. So go ahead and pull this one off, then that one off. Okay, yep. So sometimes you got to work with hot circuits. Now this is 24 volts, not going to be a big deal. Now pull it out carefully. Set that down. Now we're gonna pull these 2 wires out and isolate them. Put a wire nut on them, not together. You don't want them to short. There's one. Let's go ahead and twist on a wire nut. There's one. Pull the other one out. There's 2. Twist on a wire nut. Okay. So now those being isolated, the fire system is no longer monitoring this detector, but they're seeing a trouble condition because they don't see the resistor, but that's fine because we're in test. So let's go to the other unit now. And we're gonna do the same thing to all 3 of these units. Then we're gonna individually trigger them and see how the units respond individually without the fire alarm connected. Right. Now we have the fire alarm unwired for all 3 ACs. Now what we're gonna do is we're gonna trigger this one, see what happens. So we hold this button down. We are triggered, red light, unit shut down, and it says smoke. Let's go to the other units. Let's see if they also shut down and say smoke. They do. So they're still interconnected somehow, somewhere. This one though, still has a green, which is odd. I don't understand where they're getting their wiring from. Someone's doing something weird. Let's come over and look at this one. Same thing, smoke, and it shut down. But we go back to this one. This one, I bet you the blower's still running. Let's open this up. Yeah, the blower's still running on this one. See, it shouldn't be doing that. This unit, the blower should be off. The whole purpose of this duct detector or smoke detector is to shut down the blower in a fire situation because they don't want to fuel the fire. So let's think about it this way. If you have an exhaust system, right, and there's a fire in the building, they set off the fire suppression system. They don't want to be blowing air into the building. They only want to be sucking air out. So if there was a fire and someone set off the fire suppression, the Ansel system, in theory, majority of the time, now some municipalities may do things differently, majority of the time, you want all the exhaust fans to be forced on, even if they weren't running. They'll turn all the exhaust fans on when the fire system goes off, and it'll shut down any supply air to the building, any source of supply air. The ACs bring in outside air, so they shut those down. The makeup air unit, in theory, when the fire suppression system is triggered, should shut off too. Now, in theory, just because we trigger a smoke detector doesn't necessarily mean it's going to jump in and interlink with the fire system. So it might not be shutting down the makeup air unit, but let's go see. I'm curious, when we're in a smoke situation, if the makeup air unit's still running. Yeah, makeup air unit's running, so it's not interlinked with the makeup air unit through the ACs, but it could still be interlinked, it should be, through the fire suppression system. That's a whole nother control strategy, but this guy is not shutting down the blower, and it should be. So I'm curious if we wire this back in, if it shuts down the blower somehow. So yeah, this is really odd. All right, we're gonna reset the other one. So go ahead and reset that other unit. In order to reset it, all that you do right here, you just go to this guy and you push this button once right here. It just reset. We got a green LED flashing and the smoke should go away. Yep, it went to idle and the blower started up, okay? So this unit, smoke detector's working right. This unit though, something's still not right with this one. Now, the troubleshooting process though, what we're gonna do is we are gonna wire in this, because this is supposed to be wired in. This is powering the detector from the unit. Something's odd, and without that, I bet you there's supposed to be a jumper here too. If there's supposed to be a jumper, yellow, oh yeah. See, it might be maybe because this isn't wired in, I don't know. So we're gonna wire this in the way it's supposed to be and see how it reacts then. I realized that since they're getting the power from the other units, I tried to leave those connected and I connected these powers and it actually tripped the transformer, because then I thought about it and I'm like, oh, this is another transformer, so something happened there. So we just reset it. We're wired back in like normal. These power wires from the other unit are no longer connected. I just wire nutted them together. So then we can troubleshoot a little bit more. Now we want to trigger this thing again and see what happens. So we're going to trigger this one individually, right? So here we go. There we go, we went red, okay. It triggered smoke, but the blower still did not shut off. See, that's not right. So even with this undone, that blower should be shutting off. But I'm curious if we go to the other units, if they say smoke now too. I have a feeling no. See, this one doesn't say smoke anymore. This one says fan only, okay? So someone has these wired incorrectly. The way they're doing things is wrong. So this one says smoke still, this one does not. Yeah, this is really odd. I'm curious where someone didn't know what they were doing when they were wiring these things up. And this, I find this so much, it's bizarre. Yeah, see this one, this stuff is disconnected too, these wires. So yeah, we got to get that out of the picture because these things can't work right. Bottom line, these units need to be shut down. Emergency stop needs to be turning off the blower, and it's not. So we need to get this one wired back in correctly too, from here, and then figure out where the heck these things are going wrong. This one wasn't triggering the other ACs, but after about 2-3 minutes it did. Now they all say smoke, and it shut down the blowers. It says smoke to me, I know it doesn't say it to you. See, this needs to be an immediate shutdown. Something is really wrong here. We need to disconnect all that nonsense and just wire into the unit and let them monitor the smoke detectors in here. Look at it, just turned on. Now it says idle. It shouldn't be doing that. This is a really messed up system. Something is wrong here. So this one still says smoke. This is the kitchen, the one that I triggered. And this one over here said smoke a second ago, or it didn't, but then it did, and then now it's turning the blower on and off. Now it says smoke. Yeah, this whole system is weird. They could have issues in the attic too. Sometimes rodents can get in here and mess with things. Okay, so we're gonna get every one of these detectors wired back into the units to where they're properly shutting them down again. This unit, so we disconnected the weird control voltage. That's out of the picture. There is an interconnection right here on this brown and this blue. And it's intermittently triggering smoke on these other units. So about every 30 seconds, the unit turns off, says smoke, then turns back on. So there's something wrong in that interconnecting wiring. And we're gonna eliminate that from the picture, cap those off, and then test the operation of the units. We still need to figure out getting that one to do an emergency shutdown. From the looks of everything, this unit has a problem in the circuit board because it doesn't have a VFD. Because the reason why I said that is the other units, the VFD is bypassed, but they're working right. When that interconnecting wiring is disconnected and you trigger the smoke detector on this one, it shuts the unit down, but it doesn't shut the blower down. The blower keeps running, but the unit acknowledges the smoke detector input and shuts down the cooling, but doesn't shut down the blower. So there's something wrong in the board. I even traced back the wire that's going to the blower, making sure the labels are correct. They are. There's no other wires there. This one is going back to the indoor blower fan terminal. You guys can see right there, it says BLWR. So that is going to the blower, and yeah, this is right. And something, yeah. So there's a problem in this board. This unit's not shutting down correctly with a smoke detector input. Something's funky there. So there's something wrong in the M2 because programming wise, it's shutting down the cooling. So the unit's recognizing the smoke detector. It's getting a smoke detector input, but the blower relay for some reason is not turning on. Okay, next question. If I disconnect G, do we lose our blower? Does the blower turn off? Let's check that. Let me get my precision screwdriver. And if we pull G, the blower should shut off. We're actually gonna pull cooling right here. All together, okay? So, unit shut down, but look, the blower's not shutting down. The only thing I could think of, the blower's still running. That's the blower contactor. It's still getting voltage with no call for G. I need to go into the programming and make sure there's not something weird set up, make sure we're on thermostat control. But yeah, the blower relay for some reason is not disengaging. So it's indicating there might be a problem with the board or the blower relay stuck shut. Because yeah, that blower contactor's still pulled in and blower's still running. But we've got no call for cooling, no call for heating, no occupied signal. I mean, we can even disconnect that. So, and the blower contactor's still running. What does this guy say? Fan only. Why? Why does it say fan only when there's no call for anything? See, something is giving this a call for fan, and we need to figure out what that is. So it could be programming, but there's something definitely in the board that's causing an issue. It could be programming or could be a hardware issue. All right, our next step is to test voltage at the contactor. So I'm gonna get in here and test this and see if we can figure out if this guy's just like stuck shut. So back in here, I gotta get back in here and test voltage. Yeah, we've got 24 volts at the contactor coming from the board on that green wire. So something is wrong, and now we're idle. It says idle, so it's not even fan only. And that contactor's still getting power. I disconnected the wire going to the board and the fan shut off. Put it back on, let's see if it turns back on. Yep, turns right back on immediately. When this just says idle, I-D-L-E. That fan should not be running right now. It leads me to think that maybe one of these relays is stuck. I don't know which relay it is though. I've pretty much proved there's a problem with the board because as the unit was sitting idle, the fan should not be running. We connected everything back up, but that fan never shuts off Immediately when you turn it on, the fan turns on. It's not wired wrong. Everything's good. We're just not disconnecting the fan relay. We had no input. Something's off on that. Something's really off. And it's not recognizing smoke detector correctly, like the fan is stuck for some reason. So there's multiple issues here. The smoke detectors were the underlying issue. They had a trip smoke detector, shut down every unit. Okay, we need to investigate those a little bit further. We'll talk to the customer about this board. I called technical support. It's always good to call tech support, even if you know how these units work. You're just sometimes having a second brain to talk to. And what he had me do was just to confirm. He had me check the limit switches to make sure the limit switch wasn't a problem. And we did. We pulled it. We checked the limit switch. Limit switch is good. Contactor still pulled in. It's a bad relay on the board. So the board has a bad relay causing this issue. I got the part numbers and stuff. We'll quote that to the customer. Now we need to proceed with going through these smoke detectors. So we've got all the smoke detectors operating the way they should be now. They're all giving unit indications that it's smoke. So that means that they're wired right. We eliminated that goofy wiring going back to the other units because it's not connected right and it's causing intermittent issues. It may be right, but for now I have it disconnected because it's not an immediate shutdown and it should be. So something's up about that, because if they have them globally connected or interconnected, they want an immediate shutdown. They don't want it to take 5 minutes and then on, off, like the other units were doing. So something's wrong there. I need to find the manual for this smoke detector to see if it was even wired right, because I don't know if it was. And but we're going to investigate the smoke detector some more. So what we're going to do is come over here and we are going to pull the covers off and investigate how dirty the detectors are. Power cycle the unit, open this up, and we're going to open this cover and see how dirty that smoke detector is. Now this one has a tamper switch on it. So when you pull it off, we have it set up to, after the cover's been off for 7 minutes, it sends a trouble signal. All right, this is the cover to the smoke detector. And look at this sensor. This sensor is impacted with grease. There's grease all in this thing. There's grease all inside that thing. That's not good. And that's not really cleanable either. You're not going to clean that. This thing needs a new sensor. This is your tamper sensor right here. So when this cover basically goes on, it pushes down these two terminals and shorts them, and then basically tells them that the cover's on completely. So let's pull the sampling tube out. Go ahead and pull, stick your finger in that, pull it out, kind of jiggle it. It's probably heavy. Go get some pliers. It's a long tube running across the thing, so sometimes you need a second one. And there should be oh my gosh. Guys, this is just ridiculous. So this smoke detector was never installed correctly. This is what I'm talking about. This smoke detector has no return vent. So there's two holes that you pop out when you install a smoke detector. This one is not popped out. So this smoke detector is only venting the air into here. It's supposed to vent the air into the supply section. Now it's kind of half-ass working because this is the supply right here. So it is, but it needs an exhaust port. So basically the sampling tube, the arrow's pointing up, so that means that the air coming down from the blower is being pushed into the sampling tube. It comes through, it's forced through the detector head. There has to be a static pressure difference. It's forced through the detector head, has to have a certain velocity of air, and then the exhaust is forced back into there. But instead, the exhaust by default is just coming into here. Now in this situation, it's actually okay, but that's not right. This thing hasn't, this is what I'm saying. These things, over 10 years, this restaurant's been in existence and this isn't set up right. This is bizarre. Okay, so here's the sampling tube, nice and dirty, impacted with dirt and grease really bad. This is a problem. We'll clean this, but inevitably this smoke detector, we're gonna probably end up replacing these because being that these things haven't been wired right, it doesn't have the exhaust port. These things, the sensor's impacted with grease. You're not going to clean that. It's probably time to change this detector assembly. We'll test and see what the other ones look like, what kind of shape they're in too. But yeah, this is a problem. I'm almost gonna, yeah, we need to see if we can get one of these. So I'm gonna do some research and see if I can find a smoke detector right now. So we already need a board too. So we got to talk to the customer, because smoke detectors and boards, they start adding up. I think this unit's worth repairing, but that's not my decision to make. So we got to talk to them and see what they want to do. Let me be clear. Technically, this works. Technically, this is okay. The sampling tube going into there, technically, because it's just recirculating the air back into the mixed air cabinet anyways, which is the same air as over there. So it's actually working, hence why you see grease on one side, not on the other. I mean, it's moving air through it, but this could be why it was tripped. It's hard to say. But I'm not going to change a sensor head on a 10-plus-year-old smoke detector. That's why I'm saying I'm going to change this detector. We're going to eliminate this. So we're going to get some information off of it. This is an OEM smoke detector. You can use a smoke detector from the supply house, but they don't have this one that wires in this way with the removable terminals and all this stuff. So you got to kind of order this from Lennox. I've been down this path a bunch. And I just wiped this down. This is the model number from System Sensor, and that's Lennox's part number 102-32501. So we'll take that information down too, see if we can find the information through Lennox's website. Okay, we are gonna go ahead and just replace the sensor head because I couldn't get this identical duct detector, and this is the one that's supposed to come apart. Technically, I could use this, but it's not quite right, kind of a thing. Plus, this one doesn't have the sensor, jumpers right there. So we're gonna pull this out, make sure we can clean this detector out properly. I believe I have a new sampling tube in the van, and we'll swap that, and then we'll swap the control section. That'll be easy over, and then we'll work on changing out the board. So what we did was we cleaned it all out inside of here. We took the air blower to it, blew everything out. I do have a new sampling tube from the van, so we're gonna get that put in. Yeah, we're just moving through it. We got the new sensor put in, and we're cutting the sampling tube because I had a generic really long one. So we're gonna cut it, we're gonna deburr it, and then put the plug in the end, and then we'll have a good sampling tube that's clean. Because the model changed from what I'm using an off-the-shelf duct detector. I'm using the control section, the numbers change, but the contacts are still the same. But if you look, aux B, 18 is normally open, aux B, 7 is normally open. So you can't just go by the color and the number, you gotta use your brain. This duct detector sensor right here is perfectly capable of doing, it does everything that this one does too, okay? So it's just a matter of paying attention, unhooking everything. So what we're gonna do is we're gonna hook everything up on this except for the fire alarm. We're gonna leave the fire alarm alone, that way we can test it. We're gonna trigger the unit, and then we're not setting off the fire alarm. Now I still had the manager put the fire system on test, but still. And then we'll just land the wires, the resistor across it when we're done, once we've tested everything and make sure it works. As we're wiring this, we're paying attention and we undid everything. So on here, gray was going to 2, we're changing it to 10. Pink was going to 1, we're changing it to 9. And we're doing it one bundle of wires at a time. So currently right now we're hooking the duct detector control. It doesn't come out all the way. You don't need to pull it out that much. It'll break it. So now we're just hooking it up. This is the unit, right, connections. This is what turns the unit on and off. So we do it one set of wires at a time. It makes much more sense that way instead of just undoing everything. Again, we're working our way through this, but as we're doing this, there's also interconnecting wiring going to the other duct detectors still too. I only disconnected one portion of it when I initially diagnosed these. We're not gonna hook that up yet. We're just gonna hook up the unit and the test and reset station, change the board, then we can fully test this unit without triggering any of the other detectors potentially, and setting off the fire alarm essentially, right? So we're doing this nice and slow. This is installed and ready to be tested, but we can't test it till we swap out the board. So we're being very careful to touch the board with the least amount of potential of static essentially, if that makes sense, right? So we're gonna go and unplug all the little guys. It's pretty plug and play on this thing. And we're going to snap them all back in place where they go, and then start the board up. We'll probably have to do a startup on the board, programming the unit like it's a new install, which shouldn't be a big deal. And then we'll get it all set up, and then we'll be ready to test it. Board is swapped out, everything's put back on. We're still gonna have to play with some stuff, and we're possibly gonna change contactors too. But we're ready to turn this on and hope nothing blows up. So we've got these guys right here that are gonna go there essentially. But I know we're gonna have to do a new unit startup on this. So for new unit startup, we're gonna go ahead and leave these out for giggles. That way it doesn't have a call or anything. It doesn't do anything. It should just turn on, and then we should go through the steps and program it. If we did everything correct, this isn't gonna blow up in our faces. So there we go. It says restart, and then I just gotta go through and set up the new unit install basically. So, and then it's just gonna ask me some questions. I'm not gonna show you guys because you're not gonna be able to see what I'm doing. We're all programmed, we're running, duct detector's ready. We're gonna trigger this because the alarm is not hooked to it. So we're gonna trigger this. Should shut my unit down on smoke. That's correct, it says smoke. Unit shut down. Now we're gonna go downstairs to the test and reset station, reset it from down there, then we prove that that works. Then we could wire the fire alarm back up and then test the unit's operation. All right, the system reset from down at the test and reset station. It's just a key on the wall, you turn it. There was people in there, so I didn't film in there. But yeah, so we've proved that the duct detector works. It's programmed to the unit right, everything's good. Now, we need to hook it back up to the fire alarm system, essentially. All right, on these contactors, the aftermarket contactors, the coil voltage is on the wrong side. See how the writing's on the top, coil voltage is on the bottom. So you gotta flip this around, but you also gotta trim this because it won't fit when it's flipped around. This little tab right here needs to be trimmed a little bit shorter because this one's shorter right here. But also, when you flip it, then the little hook thing on the back is gonna be on the wrong side too, so you gotta flip the back plate. A lot of people ask me, why don't I just flip the back plate? Well, I flipped the back plate on this one, so the hook's on the top, the voltage is on the top, right? The coil voltage, but look at the writing still upside down. So flipping the back plate doesn't do everything. You still need to flip the front plate too, because the writing to me has to be right side up. It just, my OCD kicks in. So now the writing is right side up, the coil voltage is on the top, the backing plate is able to hook around the back like it's supposed to. So that's how I set it up, but you do have to trim this little tab right here. And you notice that there's a little bit of a gap on this side because it's meant to fit the other way, but you just trim it, make sure it goes in there right, and you're good to go. And this is why we're changing these contactors. Look at these points, look at how burnt they are. Where this touches this, that's the electrical connection, and it's just all pitted out. And that's probably why the wires were burnt on the ends of the connectors, because they're not loose. But each one of these is just equally as bad inside. They're really, really pitted inside. So always pay attention to your contactors. Now the indoor blower contactor is not bad, probably because the relay was sticking and it wasn't disengaging. Because these do have a shelf life. Every time they disengage, there's gonna be an arc, and it's gonna eventually lead to this. I mean, these are a consumable item essentially. They're not meant to last forever. We got the 3 compressor contactors replaced, all 24-volt contactors with screw connections. Everything's color to color. See the discoloration, but the wires aren't loose. We inspected them, so it's more than likely just because of that pitting. But all right, we're just gonna let this guy run for a minute. We're gonna put this center mullion back in. From the start to the finish of this video, there was a couple months span in there. This was a crazy summer for us. So, you know, we started it, and then like just chaos happened this summer, and we had a lot of stuff. We've been short-staffed and all that good stuff. So it's life, it's how it goes. But inevitably, we got them taken care of. So there was clearly something wrong with the global wiring, the interconnecting wiring. So for now, we just have the units in standalone mode until the customer is supposed to do a scheduled meetup between me and the fire alarm company, and then we can try to like dial in a few other things. But at this point in time, the units are functional, they're operating. It's interesting though, chasing down these problems, and you see what I'm saying, like with smoke detectors, it's so common for me to find smoke detectors that have never worked correctly. Like there's just so many people, I think, in HVAC contractors in general that don't understand. Myself included, for the longest time, I was very ignorant to the operation of how these things worked, and they were just confusing to me. And I'll tell you, the one thing that confused the heck out of me when I tried to figure out a smoke detector, because I was like, it's just a relay, and it's when you get to the supervisory contacts. On the supervisory contact, everything's backwards. So that throws me off until you figure that out. And it doesn't do a good job in the manual of explaining the supervisory contacts to anybody. And you know, that's with these videos, like that's why I tend to focus on things such as duct detectors, because they were such a mystery to me for so long until I finally figured them out. Then it's like super easy to understand. It's just a bunch of relays, you know, and just understanding how to wire them and set them up. So in this situation, the original installing contractor, what they were trying to do is they were trying to set up a global shutdown. But they just don't have enough wires running from unit to unit. It's just not set up right because they were using the existing duct detectors that came in the units. They were originally wired into the control transformers. Like, it's just kind of confusing. So like I said, we got the units into standalone operation. We figured that out, but then amidst that, we found the circuit board problem, right? The relay in the circuit board was intermittent, so we went ahead and fixed the circuit board too, obviously changed it. I get a lot of people asking me, why don't I try to repair that little relay inside that circuit board is super easy to replace. Like, why don't I just unsolder it and put a new relay on there? Because I'm not an electronics engineer, okay? I realize it's probably not too complicated, but it's not something that I do on a regular basis. And my customers need dependability, and they need 100% guarantee that it's going to work. Well, the only way that I can say that is by going back with the factory OEM components for most cases, right? The smoke detector, I don't mind changing just a smoke detector. Like, that doesn't necessarily have to be the Linux ones. On another note, getting the Linux duct detectors can be a chore sometimes. When you do find them, I usually order a couple of them because you can order a whole kit, but it's rather difficult sometimes to get the OEM ones. And so that's why in this situation I used an aftermarket detector and just made it work. Excuse me, there's a bug climbing on my glasses, like flying around like a gnat or something. Anyways, so I try to let my apprentices do as much of the work as possible, but there's also a point in time when I kind of have to take over because of certain situations. But for the most part, I tried to let the apprentices do most of the work with my guidance in this video. Yeah, and that's that. The contactors, that's another thing I want to talk about because people in my comments, they say, or in emails and comments and whatever, they say, yeah, but that contactor was fine. That contactor was fine. You didn't need to change it. But here's the thing. A contactor is good until it's not. And a contactor is a very cheap item compared to the loads that it is controlling, such as the 5 horsepower indoor blower motor, or such as the, 5-ton compressor. And when you start to get that pitting, something that you have to understand is that contactor, number one, has a shelf life, right? On, off, multiple times a day. Probably a couple hundred times, well, maybe 100 times a day or something, right? Or who knows what they are. But I mean, they basically make a connection. And every time that contactor disengages, there's going to be an arc. When that arc happens, that's when you start to get that pitting and that buildup. But the other thing to understand is just because you don't see a voltage drop and you don't measure resistance across a closed contactor doesn't mean there's not a problem, because every time that contactor disengages and re-engages, there's potential that it's not going to disengage and re-engage in the exact same position as it was before. And that arcing can cause buildup. So you as a technician have to make decisions, educated, and give the customer information and change the contactors before they fail. Because when a contactor fails, it has the potential to ruin whatever load it is controlling. So something to think about with that. When you see pitting, yeah, I've seen contactors that are much worse than this working, but you're living on borrowed time. And that potential to damage whatever component that contactor is controlling is very, very high when you start to see that pitting. So keep that in mind when you are considering replacing contactors. Now, in the situation of this video, I did not change the blower contactor because that one does not have as many on and off situations per day as the compressor contactors do. Because the indoor blower motor, for the most part, on these units, turns on one time a day and turns off one time a day in my area. Now, I realize in other areas of the country, you may not run your blowers in the on position throughout the day, but whenever my building is occupied, that blower is running for air balance reasons in my area, okay? So the blower contactors were fine. No sense in making the customer spend a bunch of extra money for that extra contactor. Even if it is another 40 or 50 bucks, it's not that much, but still. I'm not here to rip off my customers. I'm here to do my customers a service and try to prevent equipment breakdown in awkward times, right? If I can do some maintenance when they do have a breakdown and kind of look at everything and say, hey, this component is about to fail, in my eyes, that is better to do, as opposed to waiting until it just finally dies, because who knows if it's going to die at a convenient time for the customer. Maybe they're going to have a building full and it's going to be 110 degrees outside and their whole AC goes down, so it's like, you got to start thinking big here. I am sure there's things I forgot to cover. I know this was a long one. Feel free to shoot me an email, hvacrvideos@gmail.com. Leave me some comments down in the YouTube comments. Let me know what you think. I really, really appreciate you guys making it to the end. Thank you so very much. If you haven't already, please consider subscribing to this YouTube channel. If you're interested in supporting the channel, there's a couple different ways to do so. The easiest way to support this channel is just watch the videos from beginning to end. Okay? That is the easiest way. You can also go to my website, hvacrvideos.com, where we have merchandise such as these hats available. We have a couple stickers on there. It's a great way to help support the channel. It's a family operation we have going. My wife handles the fulfillment, packaging, the processing of all the orders. So, it's a great way. Again, hvacrvideos.com. You can also go to truetechtools.com, where I get a good majority of my tools from. I actually have an affiliate program set up with TrueTech Tools. So truetechtools.com. If you find something you like on their website, you put it in your cart, and at checkout, there's a little spot for an offer code, a gift certificate, or a discount code, right? If you put in my affiliate code, big picture, one word, right? No spacing, just big picture. It applies to majority of the items on their website. If it does apply to the item that you're purchasing, I get a small commission from that, and you get a little discount on that. So it's a great way to help support the channel. Last but not least, PayPal, Patreon, or YouTube channel memberships. Those are all just different ways that you can choose to make a monthly commitment, a one-time donation to the channel. There's links in the show notes of this video. I really do appreciate you, and I'm sure there's things I forgot to cover. Shoot me an email or leave me a comment. Tell me what I forgot to address, and we can talk some more. Thank you so very much. I really do appreciate you, and hope to catch you on the next one.